going to be talking about the law of refraction. And what is refraction? Refraction is simply the change in direction of light wave when it travels from one medium to another medium of different densities. When there's a change in direction of light wave, when they travel from one medium, not light wave, wave generally, all right? But we're going to be using light for example. When it travels from one medium to another medium of different density, we're going to be having what we call change in direction, and that change in direction is called refraction. And remember, two medium of different density could be from water to light to air, or from air to water. Petrol also have a different medium from water, all right? But let's use glass also from air to glass. So refraction looks something like this. Let's say you have a glass here, all right? And the light wave is coming in. This is a normal. The light wave coming this way. When it gets to this point, it's going to bend this way. So this is incident ray. These are normal. Normal is just the angle that is perpendicular to the surface, and this is a refracted ray. Now this is our angle of incidence. Note that angle of incidence is the angle that the incident ray makes with the normal, and refracted angle of refraction is also the angle the incident ray make with the normal, not the angle that it makes to the plane surface. All right, so this is medium 1, this is medium 2. The density of glass is different from the density of the air where the light is coming from, and that is why you have refraction. Normally the light should have traveled on this straight line, but it has been refracted. All right, so this is refraction of light. Change in the direction of light when it travels between medium of two different density. All right, now where do you have example of refraction? You can get an example of refraction when you put a ruler inside water. What do you notice? You notice it seems as if the ruler is bent. That is refraction. That's the phenomenon. If you are standing inside water also, you know there's what we call real depth and apparent depth. Why do you look at water or swimming pool as if it's not as deep as it is? It's actually deep, but because of refraction, the depth looks like if it's not that deep. All right, so let's go straight to law of refraction. The law of refraction states that there are two laws. The first law is that the incident ray, the normal, and the refracted ray at the point of incidence all lies on the same plane. The incident ray, the normal, and the refracted ray at the point of incidence all lies on the same plane. That almost sounds like the same thing as the first law of reflection. Incident ray, normal, and reflected ray. You can check my class on reflection. Second law of refraction now says that the sine of the angle of incidence over the sine of the angle of refraction is constant for a pair of medium. So the sine of angle of incidence to the sine of angle of refraction is constant for a pair of medium. For example, for air to water is constant, for water to kerosene is constant, from air to glass is constant, and this is called refractive index. All right, so refractive index is what? Sine I over sine R. That's the second law of refraction. The first law, incidence ray, normal, and the refracted ray at the point of incidence all lies on the same plane. Second law, the sine of angle of incidence to the ratio of the sine of angle of incidence to the sine of angle of refraction is constant for a pair of medium. The ratio of the sine of angle of incidence to the sine of angle of refraction is constant for a pair of medium, and this is known as refractive index. If this class has been of use, make sure you like and share and subscribe, and if you have any question, kindly ask your question, and make sure you do what? You study and succeed, and make sure that your incident ray, your normal, and your angle, your refracted ray at the point of incidence all lies on the same plane. Thank you and bye bye. Hasta la vista.